Okay. So let's suppose we have requirement, right? So if you remember last class we were discussing about the design part. Like I have one head office and multiple branch office, and we were taking a single subnet. In that case, we had problem. So let's recap that and we'll move further. So let's suppose I have a branch here. This is my headquarter, and this headquarter is having some branch offices. Branch 1, branch 2, branch 3, branch 4. And we are getting one IP address 16.20.0.0/22. This IP address we got from organization. Now they are asking us to design this network. So to design this network, we need to understand the design consideration. So the first is, as per the design rule, the first design rule. First is no two ports of router can be in same subnet. Second, directly connected interfaces must be in same subnet. So this is the design rule. Now, if you start assigning the IP address, so let's suppose here I am assigning the IP address 16.20.0.1, then 16.20.0.2, then .3 here, .4, .5, .6, .7, and .8. Similarly, we'll also have the network in the LAN side. So we'll assign here .9, .10, .11, .12. So I have a single subnet that I can use to assign the IP address. Now, if you consider the design rule, it's saying no two ports of router in same subnet. That means this interface and this interface cannot be in same subnet. But here we are putting into the same subnet. So from the first rule, this is not possible. Second is saying directly connected interface must be in same subnet. Means this interface, if I talk about this interface, so this interface is connected with this router, branch 4 router, it's saying must be in same subnet. So .7, .8, I can assign this IP address here. So if I consider this diagram and let's make it sequence number 1 and 2. If this is sequence number 1, then it's saying directly connected interface must be in same subnet. So from the first rule, it's true. We can achieve that. But if you consider the second statement, it's saying no two ports of router. No two ports of router means this port and this port, it cannot be in same subnet. So from design point of view, this IP assignment is incorrect. You cannot use this IP assignment to design our network. So it's a totally wrong. The IP address which you have assigned here is totally wrong. Then what is the solution? If you understand, if having the multiple branch offices, if they are geographically separated with each other, then we have to connect with them. To connect those sites, we can use the WAN technology or MAN technology, wide area network or metropolitan area network. This technology we can use to connect them. So in that case, if we are using that and we are assigning the same IP address, on the router interface, on the directly connected interface. So this design, this from the design point of view, we cannot do this. Then solution is the subnetting, right? So let's understand the subnetting. Okay. Before understanding the subnetting, let's understand these some scenarios. So the entire IP address, entire devices, entire location are in the same subnet. So the question will come, instead of having router, I can use the switch, because switches within the subnet, router routes in between the subnets. So I can use the switch, right? So from router point of view, this design is totally wrong, because from the router point of view, you have to consider the design rule. And the design rule says directly connected interface must be in same subnet, and no two ports of router can be in same subnet. So instead of this thing, if I use the switch, let's put the switch here. Let's suppose this is a switch. Switch 1, switch 2. And I have some more switches here. And some PCs are connected here. Right? And if I have the same IP address, that is what 16.20.0.0/24. So from the design rule, the first is directly connected interface. If this is the switch 1 and this is switch 2, this is switch 3, switch 4, switch 5, and switch 6. So what I can do, I can put entire thing into the same subnet, because switches within the subnet, means in a single subnet. A router routes between the subnets. So within the subnet means all the PCs I can put into the same subnet, right? So that means the first criteria, that no two ports of router. But if that is the switch, I can have the interface with the same subnet, right? Second is directly connected interface must be in same subnet, right? So this is also in same subnet. This all in same subnet. That means from the switch point of view, I can achieve the requirement. But let's see what is the problem here. Let's suppose this is the PC A, B, and this is C, D, and this is E, F. Now, this guy is A, came early morning in the office, right? And he will get the PC here. Will get the PC with the switch. And this guy wants to have a communication with guy C. So A wants to have a communication with C. This is the requirement. Now, if you remember, if any MAC address is not sending or receiving a frame for 5 minutes, it will consider that as a tail entry and it will remove. So in the last night, right? The guy is coming in the morning, means last time he logged in the evening. Now they say entire like 10 or 12 hours. Definitely MAC address would want to be there in the MAC table. In that case, what will happen? This will come here, right? This will come here, and switch 5 doesn't know where C is connected. In that case, switch is going to create a multiple copy. Remember, switch creates the multiple copy in two ways. One, broadcast frame. Another is if switch doesn't know the MAC address. In this particular case, switch 5 doesn't know where C is connected. In that case, switch is going to create the multiple copy and it will forward to all other interfaces. So it will create a multiple copy, it will forward here and here. It will come to switch 2. Switch 2 will forward here, here. It will come to switch 1. Switch 1 will forward here, here, then here, here. So destination MAC address is unknown. Because of that, switch is creating a multiple copy of frame and forwarding to all the switches and all the PCs. And this is the broadcast frame. The broadcast frame, right? This is the case with the single PC. What if you have thousands of the PC, right? If you have thousands of the PC in the network, but this guy will also come early in the morning, right? This guy will come also, and this guy also don't know what is the MAC address of A and what is the MAC address of B and what is the MAC address of the E and F, right? Don't you think it would be broadcast form? If all the switches are forwarding the broadcast frame because the switch doesn't know the destination MAC address of on which interface destination MAC address is connected. Because at the initial level they don't know, and they start processing the broadcast frame. This is for the single PC and multiple PCs. What if we have some application that needs to be broadcasted? You are accessing some server. You are accessing some. When you come into the office, first of all you need the IP address. IP address means here DORA process will run. DORA process will run. In that, the first packet is broadcast frame. Broadcast. The first is broadcast. DORA means discover. Discover, offer, release, request and acknowledge. D, discover is the itself a broadcast frame. So all the PCs are sending a broadcast message into the switch, into the domain to get the IP address from DSCP. And that is the first point. Second point is if this PC A wants to have a communication with B, C, in that case also switch 5 doesn't know where the C is connected. Again broadcast frame. So what is going to happen here? Your network will go totally down. Because switch is busy in the processing of the broadcast frame. At the same time, if any legitimate packet or legitimate frame comes, switch will not process because it will say, wait, I am processing the broadcast frame. This is the first problem. Second problem is what? Let's suppose this is the office in India. And this is somewhere in US. And you have a link from India to US, let's suppose 2 MB link to forward your data. But if you remember the broadcast frame which is generated here, the broadcast frame which is generated here, it is also going to US. And it's very highly that you have to pay a lot of money to get the 2 MB link because that is the long distance communication. Not US is not US, right? So if you have the link of the 2 crores, you are paying a 2 crores to reach to the US, and that link you are using just to forward the broadcast frame, not the data. Data you are not forwarding. Data is still under the processing because the switches are busy into processing of the broadcast frame. So first problem, this is the second problem, right? You are paying a lot of money to the ISP, and that link you are using to process your broadcast frame. That is why, because you are saying I will not use the router, I will use the switch. If you use the switch, this is the problem. First problem is you will get the broadcast store. All the PC will create the broadcast frame and they will start processing those. Second is cost, deployment of the cost. Cost is become more, right? You are paying a 2 crores of the 2 crore and you are using that link just to forward the broadcast frame and you are saying no. Why? Because you want to use the switch. So this is also not feasible. So you have to go with the router. Router is the single solution because router itself saying router routes between the subnets and switch within the subnets, right? So if you are going within the subnet means a particular small branch of it. This is a small branch of it. I can use the switch here. But at the moment, if you want to go out of this network, you have to use the router. You have to have the LC connectivity. What is the advantage with the LC connectivity? If you remember, switch, they are having the multiple collision domain and single broadcast domain. The broadcast which is coming on this interface, it is going everywhere. In the router is the member of separate collision and separate broadcast domain. That means if a router is here, if any broadcast comes on the interface, it will not get forwarded to other interface because router, every interface is the member of separate collision domain and separate broadcast domain. If broadcast comes on this interface, it will not go on the other interface. It will be there on the router itself, on the interface, on the router, on that interface only. It would not go to the other interface. So let's suppose this switch is having the broadcast. Let's suppose this switch is this switch, right, doesn't know any MAC address, A and B. If switch doesn't know the MAC address, what is going to happen? Switch will get a multiple copy. It will send a broadcast to the router, but router will not forward that because the behavior of the router is to have the separate collision and separate broadcast. That is why, if you remember, when we have the communication with different subnet, like destination MAC address is always router MAC. If you recall the packet flow, if you have a communication with different subnet, remember the router was there, switches were there, right? When we have the communication with different subnet, at that time we were using the router MAC address, not the destination MAC address. In that case, instead of having a PCA MAC address as a destination, it will use the router MAC address, right? So there are two problems when you have the switch. The first is broadcast or second is the cost. So definitely we have to go with the router. If you go with the router, then we have to do the subnet, right? So let's come here. Subnetting. So let's take the same scenario. I have a router. This is my headquarter, and this is the branch office. This is another branch office, and another branch. This is branch 1. Branch 2, branch 3, branch 4. And this is my LAN segment. And I am getting an IP address. Okay. So let's understand this from the scenario point of view. Right? Now, there is a company called ABC. This company ABC wants to open some offices in Hyderabad. They already have an office in Hyderabad, right? They already have an office headquarter here. They want to extend their network. They want to extend their office. And being a network engineer, we are working there. Correct? Now they are saying, everybody, we need to have the 4 branch offices in Hyderabad. In that case, what is going to happen? You have to design this network. So you will recall that, okay, just now I have completed the subnetting, so definitely I can design this network. Right? So if you say yes, then manager is giving IP address 16.20.20.0/24. And he's also saying that at the branch office, you have the requirement to sit 20 users. At the branch office 2, we have the requirement to sit 30 users. Branch 3, you have the requirement to use to sit 10 users, and branch 4, you have the requirement to use 24 users. You have the requirement to sit. It's a total count. Means in that you have your PCs, you have a laptop, you will have your printer, you will have your attendance as well. Like you have the punching machine. So this 20, 30, 10, and 24, these are the total count. In that you might have server, you might have printer, PCs are there, and you also have the scanner, fingerprint scanner for your attendance purpose. So these are the requirements, right? Now you start thinking, okay, I got one IP address. Let's do one thing. Let's assign this IP address here. I have assigned 20.1 here and 20.2. Then I started assigning .3 and .4. Immediately, you recall the design rule. And design rule says, first, directly connected interface must be same subnet. That's fine. This interface directly connected, they are in the same subnet. Second rule, no 2 ports of router can be in same subnet. So the moment you assign .3 here, these 2 interface will be in same subnet. Right? That means this design is incorrect. Now you are thinking, okay, let's go to my manager and let me ask another subnet. Before reaching out to them, again you recall, okay, I have finished the subnetting. Let me do the subnetting, because again you will think, if I go with this question with the manager, then he will ask, okay, why do you need the IP address? This /24 IP address which we have here, it's enough to design the network. Let's suppose you went to manager and you asked, sir, this IP address, the IP address which you have given is not sufficient to design the network. I need additional IP address. And he will reply, really, you need the additional IP address. Then question will come to me. The question will come on us. Why is asking like that, and why is he saying like that? Do you really need the additional IP address? Okay, we are the smart guys, definitely. Immediately subnetting came in your mind. No, so sorry, sir. Okay, now I got it. I can design it. Now you came back to your desk and pull up your pen and paper and start doing the subnetting. Right? So when you do the subnetting, again the question will come, how would I do the subnetting? So there are two ways to do the subnetting, types of the subnetting. First is subnetting from host point of view. Second is subnetting from network point of view. When you open a notebook, you will see that I have written a subnetting from host point of view and subnetting from network point of view. Right? So let's discuss one by one. Right on? Okay, let's remove it. So first is saying subnetting from host point of view. Subnetting from host point of view. Not done. Done, right? No, write down. So subnetting from host point of view and subnetting from network point of view. So let's remove it and let's understand first. From the design rule, this interface and this interface must be in same subnet. That means I need one subnet here. This interface and this interface must be in same subnet. Another interface, another subnet. Second number. This subnet and this interface was third. This one and this one. 4. Correct? This is the WAN connectivity. If I have the branch, if I have my headquarters here and another branch office outside, somewhere in Secunderabad or something, right? So if they are connected, then they must be connected over the WAN technology or MAN technology, right? So this is one thing. And what about the user which are sitting here? For them also, I need another subnet here. This interface and this interface cannot be in same subnet. Definitely, I have to have the different subnet. So 4, this is 5th. Again 6, 7, and 8. So total, how many subnets we need? 8, right? If this is the requirement, if this is the scenario where we have to design the network and we have that IP address, so total we need the 8 subnets. But what we have here, we have a single subnet, right? This is the single subnet, and all the IP addresses are part of the same subnet. So if you give me the answer, this tells the number of the bits into the network side. How many bits? 24 bits. Second, in host side, 8 bits. With the help of the 8 bits, we'll get the to the power 8 means total 256 IP address. And this is the class A IP address, na? First octet tells the class of the IP address. 16, right? It comes between 1 to 126. Class A IP address, right? Okay, and this is what? 4th. This is the classless or classful? This is a classless IP address or classful IP address? Classful. Subnet mask greater than the default mask. Classless. What is the class A? Class of the IP address A. And for the class A, default mask is /8. What we have here? /24. So IP address not with the default mask. It's a class less IP address. So this information we have, right? Now, total number of network required. Total number of the network. Eight. Right? Now, total IP address I have what? 256. If I write here 16.20.20.0/24 means host bit 8. With the help of that, I will get to the power 8 means total 256. Correct? This 256 I have to divide into the small. In that is also small so that I can get the total 8 network. Right? So I have the big pool. I need to divide so that I can get the 8 network. So what I will do, I will divide this with the 8. 256 divided by 8. It would come 32. Right? So this total 256 IP address, now I am dividing 32. Right? So if you multiply this thing 32 into 8, you will get total 256. Right? That means block of the IP address. 32. Right? So this is the subnetting. I have a very big pool. Right? In that total, I have the 256 IP address. Now what I'm going to do, I am dividing that into the 32. Right? And the IP address start from the 0 and it will go till 255. The range which we are seeing here is basically 0 to 255. Total is what? 256. Starting with the 0, right? Starting with the 0 is going to till 255. Total is 256. Right? So the range will start from 0 and the difference will be 32. Right? So let's write down. This is they are getting again. So the actual IP address is 16.20.20.0/20. 16.20.20.0. Difference is what? 32, right? The next will start from 16.20.20.32 till 63, right? The next will start from 16.20.20.64 till 95, right? Then next will start from, okay, let's write here 16.20.20.96 till 127, right? Then 16.20.20.128 till 159. Then 16.20.20.160 till 191. Then 16.20.20.192 till 223. Right? The next is 16.20.20.224 to 255. And everywhere we have the difference of 32. If I write this thing separately, it will start from 0, 1, 2, 3, 4, 31. Then 32, 33, 34, like that it will go, right? Now, if you count this thing, let's count it. First, second, third, fourth, 5, 6, 7, and 8. So I had a IP address starting from 0 till 255, means total 256. Now I have divided that IP address into the block of 32, 32. With that, I am getting total 8 network. And what was the requirement? 8 network. I had the requirement of 8 network. Now I am getting the 8 network. Right? I can assign this network there. I can. What I can do, I can pick one subnet here. Like I can pick the starting one. That okay. I can pick first one, like 16.20.20.0 till 31. I can pick that. I can assign that. But the question here is, how would I get this? What is the value here? Right? So I did the subnetting, but the point here is the IP address which I have from my organization, that is something like this. This is /24 notation. But I don't have anything here. Right? This is what we have to identify. How to calculate this thing? Let's come. So if I write this IP address once again, 16.20.20.0/24, right? Now, when I divide 8, 256, we'll get 32. Now, to achieve this 32, what we need to do? If you do 2 to the power 4, like if you remember, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. This is 1, 2, 4, 8, 16, 32, 64, 128. Where I am getting to 32?